In 2014, a team of scientists announced they had weighed the largest animal ever to walk on land. 59 tons. Roughly a dozen elephants, standing in one body. 9 months later, another team weighed the same dinosaur and got 30 tons. Not 30% off. Half the animal. Gone. This is Ashborne Ancestors. And the strangest part of this story is that neither team made a mistake. So here is where we are going. I am going to show you how you actually put a dinosaur on a scale, which turns out to be two completely different sciences that hate each other. Then I am going to show you why both answers might be wrong for the same reason. And at the end, I am going to tell you the thing that genuinely unsettled me, which is that the biggest land animal that ever lived is almost certainly not the one in this video, and we will probably never be able to weigh it. Let us go to Patagonia. In the Badlands of southern Argentina, in rock laid down about 77 million years ago, a team led by a paleontologist named Kenneth Lacovara spent 4 field seasons pulling an enormous skeleton out of the ground. It was a titanosaur. A long-necked, long-tailed plant eater, one of the sauropods, the group that contains every truly gigantic land animal that has ever existed. This one stretched around 26 meters, from nose to tail tip. They named it Dreadnoughtus. It means, roughly, fears nothing. And when you look at an adult of this size, that is not poetry. It is a description. Nothing in that landscape could threaten it, not a pack, not an ambush, nothing. But the name is, the bones are. Here is the problem with giant dinosaurs, and almost nobody tells you this part. The famous ones, the ones with the biggest numbers next to their names, are mostly missing. Argentinosaurus, a name you have probably heard as the largest dinosaur of all time, is known from about 13 bones. 13. Out of a skeleton that would have held roughly 250. You cannot weigh that. What you can do is find a relative, guess the proportions, and scale up. Every giant on every poster is, to some degree, an extrapolation wearing a number. Dreadnoughtus was different. The team recovered over 100 bones, and more importantly, about 70% of the distinct bone types in the body, excluding the skull, shoulder, limbs, vertebrae, the actual load-bearing architecture. For the first time, somebody had a supermassive dinosaur, complete enough to genuinely measure. So they measured it. And the number was 59 tons. Now, how do you weigh something that has been dead for 77 million years? Method 1 is beautifully simple. Take the femur and the humerus, the great weight-bearing bones of the back and front legs. Measure the circumference of each. Then feed those two numbers into an equation. That equation was not invented for dinosaurs. It was built by measuring living animals, hundreds of them, from mice to elephants, and finding a consistent relationship between how thick your leg bones are and how much body they are holding up. Bone has to be thick enough to carry the animal. Physics does not negotiate. Lacovara's team ran Dreadnoughtus through that equation and got 59 tons. The heaviest land animal ever reliably calculated. It went everywhere. Every headline. Every list. And then, in 2015, a team led by Carl Bates published a paper in Biology, Letters with a title that does not bother being polite. Downsizing a giant. They used method 2. Instead of scaling from bone thickness, they built the animal. A 3-dimensional digital skeleton, then flesh wrapped around it, then muscle, then the air. Because a sauropod is not solid meat. Its neck and body carried enormous air sacs. Like a bird, hollow spaces that weigh nothing. You can inflate that model, or slim it down, and see what the animal plausibly weighed at each version. And when they did it, across a wide range of reasonable builds, Dreadnoughtus kept landing between 30 and 40 tons. The heaviest land animal we had ever calculated had just lost the equivalent of 4 elephants. Lacovara did not take that quietly, and I think his objection is a good one. So let me give it properly. His argument is that the scaling equation works. It has been checked against living animals over and over. And if Dreadnoughtus really weighed 30 tons, then its leg bones were dramatically thicker than they needed to be. Bone is expensive to grow. Animals do not carry pointless armor in their thighs. To which the other side answers, roughly, that no living animal is anywhere near this size. So you are extending a formula far past anything it was ever tested on. And honestly, they are both right, and that is what makes this interesting rather than annoying. One method trusts the bones. The other trusts the body. Neither can be checked. Because we cannot go and find one and put it on a scale. I have read both sides. And I will tell you where I land. And you should feel free to tell me I am wrong. I think the volumetric number is probably closer, and I think Lacovara's objection about the leg bones is the single best unanswered point in the whole argument. Both of those can be true. But while everyone was arguing about the number, the bones were quietly saying something that makes the entire fight look smaller. They cut the humerus open. If you watched our episode on Tyrannosaurus, you already know this technique. You slice a bone thin, you put it under a microscope, and you read the growth. And what they found in Dreadnoughtus was not the bone of an adult. The tissue was fibrolamellar. That is fast-growing, richly supplied with blood vessels. The bone of an animal that is actively building itself. There were no lines of arrested growth, no rings marking hard seasons, where growth stopped. There was no external fundamental system, which is the dense outer layer that forms when a skeleton finally finishes and says, "That is it, I am done." And the shoulder blade had not fused to the coracoid, the bone beneath it. In a mature sauropod, those knit together. Read all that together and it says one thing. This animal was a teenager. 26 meters. Somewhere between 30 and 60 tons. Fears nothing. And not finished growing. So every number in this argument, the 59 and the 30 and everything in between, is not the weight of a Dreadnoughtus. It is the weight of a Dreadnoughtus that had not become one yet. It is a floor. Nobody knows the ceiling. Nobody has ever found one. That is where this stops being a story about a scale, and starts being something else. Because now, put the two facts side by side. The one supermassive dinosaur can enough to actually measure was a juvenile, and the ones that were probably bigger, Argentinosaurus and its kind, survive as a scatter of 13 bones and a hopeful equation. Which means the honest answer to how big was the largest animal that ever walked the earth is that we do not know. We have never held a fully grown one. We have never weighed one we could trust. The record book of the largest creatures in history is a book of estimates made from children using formulas built on mice and elephants. I find that harder to shake than any number. And notice what happened here. Because it happened in our last episode too. With Tyrannosaurus, we discovered the animal on every poster was middle-aged and had spent decades as something leaner. With Dreadnoughtus, we discovered the animal on every poster had not even finished. Two of the most famous creatures that ever lived, and in both cases the version we built our imagination around is a stage, not a destination. We keep meeting these animals in the middle of their lives, and mistaking that for the whole story. Somewhere in Patagonia, under rock, there is an adult Dreadnoughtus. Bigger than this one. Heavier than any number in this video. Its shoulder fused, its growth lines finally written into the bone, the thing this one was on its way to becoming. Nobody has found it yet. Tell me in the comments which method you trust. The bones, or the body. And, if you think I picked the wrong side, say so, because I am not confident, and I would rather be corrected than comfortable. And subscribe, because next time we going somewhere the numbers get even worse. An animal we cannot weigh, cannot measure, and cannot classify, because we have exactly one piece of it. This has been Ashborne Ancestors. Before history was written, survival was the story.